Have you ever stopped to think about the hidden rules that run our lives? I'm talking about a secret mathematical language that's everywhere, from speed limits to your budget to your personal goals. Today, we're going to decode that language. We're going to uncover the simple yet super powerful symbols that write the rules for just about everything. So, let's just start with a little puzzle. I want you to think about all the limits and boundaries you bump into every single day. Like the minimum score you need to pass a test, or the maximum number of people allowed in an elevator. How do you actually write those rules down so there is zero room for confusion? Okay, take a look at this. A box can hold up to 20 books. Simple enough, right? We all get it. You can put 10 books in, 15, heck, even exactly 20. But you absolutely cannot put 21 books in there. But how would you tell a computer that? Or write it into a contract? We need a way to state that limit with total precision. Well, it turns out there's a special language for doing just that. And honestly, it's only made up of a few key symbols. This is the language of inequalities, and it's what tells us what's possible and what's allowed. First up, we've got this one, greater than. It's exactly what it sounds like. You use it when one thing has to be bigger than another. Like, to win the grand prize, your score has to be greater than 100. A score of 100 exactly? Sorry, that won't cut it. And on the flip side, of course, you've got its opposite, less than. This is for when something has to be smaller. Maybe the time to finish a race has to be less than 5 minutes. If you come in at exactly 5 minutes, you're just a little too slow. But, this is where it gets really useful, when we add this one tiny detail. See that little line underneath? This symbol means greater than or equal to. It sets a minimum. You need a score of 70 or higher to pass. A 70 is good enough. You're in. In its partner, less than or equal to sets a maximum limit you just can't go past. Remember our box? It can hold up to 20 books. That phrase up to is the big clue. It means 20 is totally fine, but 21 is a no-go. So yeah, that tiny little line, it makes all the difference in the world. It's the difference between including the boundary number itself or not. Think about it. Does a rule say under 18 or 18 and under? That one little line changes everything. Let's look at a school rule to really see this in action. A student can miss no more than 5 classes. Okay, that phrase, no more than, what does it really mean? It tells us 5 is the absolute limit, but missing exactly 5 classes is still allowed. So we use less than or equal to. The number of classes you miss, let's just call that X, has to be less than or equal to 5. Okay, so we've got the basic vocabulary down. Now let's put it to the test with a real-world example. Let's talk about a fundraiser with a very specific make-or-break goal. The group has a super clear target. For their program to happen, they have to raise at least $500, not a single penny less. This is their absolute minimum for success. So how would you write that down? Think about it for a sec. That key phrase, at least. Which one of our 4 symbols perfectly captures that idea? The idea that hitting $500 is great, and anything more than that is also great. And this is it. This is how we write it. If we use X to represent the money they raise, the goal is X is greater than or equal to 500. That little statement perfectly describes what they need to do to succeed. Now here's what's so cool about inequalities. They don't just have one answer. See, an equation like X equals 5 has, one answer, 5. But in inequality, it describes a whole range of possibilities, an entire set of correct answers. So let's just walk through a classic example and see how you find that whole range of solutions. And don't worry, if you can solve a basic equation, you can totally handle this. The steps are pretty much identical. So our goal here is just to get X all by itself. First thing we're going to do is subtract 3 from both sides. That leaves us with 2x is greater than 6. Simple enough. Then we just divide both sides by 2. And that gives us our final clean inequality. And there it is, our solution, X is greater than 3. Now, this is the big takeaway. The answer isn't just one number, it's an infinite set of numbers. Is 3.1 a solution? Yep. Is 42 a solution? For sure. Is 1 million a solution? Absolutely. Any number, as long as it's bigger than 3, makes that original statement true. So, we've seen how these symbols give us really precise rules for numbers. But this whole idea of measure and value, it isn't just for math. It can actually apply to the principles we choose to live by. This verse from Luke's Gospel, it connects our mathematical idea of measure directly to generosity. It suggests that the way we measure out what we give, whether that's money or kindness or our time, that's the same standard we can expect in return. It's a really beautiful way to think about how these logical rules can echo in our lives. And that really just leaves us with one final question for you. Now that you know the language, now that you can describe limits and goals and boundaries, I want you to take a look around your own life. From your personal budget to your career goals to your health, what are the hidden inequalities that are defining the rules of your world?